Hello and welcome to Sean White's Solar and Energy Storage Podcast. Today we have a special treat. I'm a little bit intimidated here. We have somebody that is officially a 2-star general, or at least retired general, so I'm going to try to be on my best manners here, but he has given me permission to mess around a little bit. And his name is John Kim, and that's spelled K-E-M. And he is the president of the American Battery Factory. Not too long ago, we had a colleague of his that is somebody named Tyler Horton, and he also works at the American Battery Factory to a certain degree, and he was representing Lion Energy here. So really impressive to see these people doing lithium-ion batteries in the United States of America. So welcome to the show, John Kim.
Hey, Sean, thanks for having me. And thanks for mentioning my time in the Army. People in the Army sometimes would, not too many generals around. It sounds a lot cooler than it actually is, though. It's basically, obviously fun. And that means you stayed in the Army a long time because you liked it.
Well, good. I'm glad you liked it. And thank you for serving and doing all that important work. And I'm sure there's probably a whole lot you could talk about there too. But today we're going to focus on batteries because you're the president of the American Battery Factory. And so how long ago did you become president of the American Battery Factory and then get out of being the military and retired from the military? It's funny, I've met people that they're saying, oh, I'm retired from the military, and they're like 35 years old.
It takes 20 years to get half of your pay for retirement in the Army, or all the service. But you can't stay more than 30 unless you're a senior general or senior command sergeant major. So I stayed for 35 years, and I retired 3 years ago. And then I started with American Battery Factory almost a year ago, just under a year ago.
Great. Yeah, and I was thinking about that too. I'm sure that with all of this made in America stuff that we're doing, and there's a lot of geopolitics involved and kind of maybe even sort of related to national security and things that you already have experience with.
Well, there is some of that. I would say in the battery cell part, which is a precursor to lots of batteries and all the things, it's more indirect. Mm-hmm. But the whole idea of we want things made in America, we want our important national security things that you can trust them. So even if some parts don't come from the United States, do they come from somebody we know is reliable and good? So that's national security side of it. I think in terms of background, I was an engineer, and at one part of my career, I was part of the Northwestern Division of the Army Corps of Engineers, which basically does the hydropower systems, not all of it, but most for the Columbia River and the Missouri River systems. So kind of large industrial things I've been part of. I wasn't the one turning the machines and making them work, but leading and managing those organizations is my background.
Great. I have a neighbor with the Army Corps of Engineers, and he's not retired, and he goes around in the bay on a boat salvaging things, cleaning up the bay. Sounds like a pretty fun job. So I was going to ask you too, maybe if we could define what's the Army Corps of Engineers. I know everybody's heard of it, but probably don't want to ask what it means.
Well, there's two sides. So the Army has engineers, like they have infantry and artillery and everything else. And in the battlefield, the engineers are the ones who put in mines and also defeat enemies' minefields, do river crossings, and they're kind of responsible for the mobility and the counter mobility of the maneuver force. That's the traditional armies of the world. That's what engineers do. The United States has a unique side, which is the civil works and the military construction side of the Army engineers. So this literally goes back to the U.S. was moving west. Congress at one point said, Mississippi, for example, hey, the Mississippi River is complicated, messy. It's hard to navigate. It's a little bit dangerous. Can you all come through and help streamline the river system so it's better for moving traffic? And so as the country moved west, the Army was doing those things. And strangely enough, the Army still does it. So the largest hydropower producer in the United States is the Northwestern Division of the Army Corps of Engineers. No other country has their Army running the river systems. You look at most of the major harbors, San Francisco, the San Francisco district of the Army Corps of Engineers manages the main channel for the major ports of the United States. But that goes back to the 1840s when Congress said, you will help us do ports because it's part of national defense. That was kind of the idea.
Wow. Yeah, I can remember reading some books about Genghis Khan and how he was really good at moving forward. And this was long before there was the United States. And he did have a lot of engineers, and they would build ladders so they could get over the castle walls and things like that. So I guess you weren't involved in jumping castle walls, though.
Slightly before my time.
But perhaps lithium-ion batteries are somehow involved here because it's homegrown energy. I remember hearing things too in the past about how it's dangerous to have fuel convoys up in the mountains and different places that we've been. And so renewable energy might be a solution for that.
No,
But
absolutely. You think about if you go back to the military side, not when we're focusing on batteries, but in World War II, it was mostly regular gasoline like we use in cars. Eventually, people went to diesel fuel because it doesn't catch on fire as much. Well, imagine how much better it is if you have a battery, and then unlike the NMC kind of batteries that do catch on fire and it's hard to put the fire out, lithium iron phosphate batteries don't really catch on fire the same way. So you have a safety component and a reusable component that all has value added, right, as you transition.
Yeah, great. I always like to define things as we go along. So we're talking about lithium iron phosphate batteries, and the abbreviation for that is LFP. F is the chemistry symbol for iron, Fe, and it's a type of a lithium ion battery. So LFP isn't different from lithium ion. It's one type, and it doesn't contain cobalt and nickel like the batteries that hold a little bit more energy per weight. We call that specific energy as energy per weight. And it's a lot safer than when you're talking about the lithium iron phosphate. So that is great. And also, I know that you're in the process of building a big factory, and I guess it's called a Gigafactory in Arizona. And are you involved with building the factory on a day-to-day basis, or how's that work?
Well, absolutely. So a couple of comments with that. So, I mean, it's the first factory we're building is just south of Tucson, below the airport, on about 70 acres of land that we have a lease to buy from Pima County, who had the land. And it's mostly, there's not much there. It's pretty empty kind of desert. And so our first factory is going to be two different 2 gigawatt hour lines, right? So that's why we call it a gigawatt factory. Mm-hmm. So in a year, each line can do about 2 gigawatts worth of batteries.
Great. So that would be
a 4 gigawatt facility. And that's why we call it, because it's gigawatt scale. That's how much you're going to produce in a year at full capacity.
Or I guess with batteries would be gigawatt hour then, rather than gigawatt?
Typically, yes. I mean, in the end, it's a gigawatt hour, 4 gigawatt hours worth of battery cells in a year.
I guess if we shorted those batteries out, then 4 gigawatt hours would be a lot more than 4 gigawatts at short circuit current. But
right.
Don't want to do that, though. Then we could be doing some fire experiments and things like that. And so When we talk about fire experiments and stuff too, that's when we get to the UL testing and things like that. You were just building the cells, right?
Right. We still have a UL component to this. So we're going to build battery cell factory. One of the challenges right now is when you buy the battery storage solution people, right? You go to Costco, you go to the places and you buy a storage thing on your garage wall or backup power for your house or for small industrial applications or even for cars. Almost all those battery cells are made in China mostly, and then a few other places, right? And the battery cell is really probably 60% of the important parts of that battery storage solution, right? If you don't have the battery cells, then all the electronics and everything else have nothing, they're worthless, right? So when people say they make the battery storage solution in the United States, at this point, the answer is not really. Because almost none of the battery cells are made in the US, or if they are a little bit, they're kind of packaged, but almost all the stuff is coming, it's mostly already done and the final assembly is happening. So we're trying to be from soup to nuts, right? We're trying to be from raw materials all the way through production of the battery cell. It's all done in the US, maybe a little bit of North America if it's not available in the US.
And so if you're going from, like you said, soup to nuts, so are we talking mining, like getting the lithium out of the ground in the US or North America?
Yes, but we're in the battery cell business. We're not trying to be like some people trying to do the whole supply chain from the very first piece to the very end. We're not. We're trying to produce battery cells and buy raw materials to do that. Like, for example, so we're not going to mine lithium. There are companies that we're working with in the United States that are in Canada, like First Phosphate is one of them in Canada, starting lithium mining processing. And you see stuff we read all the time about in the Great Salt Lake area and the Salton Sea in California on the availability of the lithium and the iron and the phosphate you talked before and some of the other materials. And so we're working with all those companies because we want what they're producing. The challenge we have in the near term is that's also kind of new, right? And so even people that say, hey, we think we have lithium, right? Well, how much do you have? Well, I'll give you an example. lithium iron phosphate in the first year of a first full year of production, we need 7,000 tons. Well, that's a lot. Most of the plate people in the US that are going to, and Canada, they're starting to do it, are going, well, in the first year will be about 26 or 25. We're going to have 400 tons or 800 tons, and we'll be at blank by 2028 or 29. So eventually it will come, right? But it isn't necessarily all available in a reliable way. It's not like getting oil or getting solar panels where there's a routine to it at this point. There's no routine to this supply chain.
So you're talking about using way more lithium than there is produced in the United States right now.
I wouldn't say more lithium. I would say the challenge is we need lithium iron phosphate. So you need lithium, you need the iron, you need the phosphate at certain quality, right? I'll give you an example. The lithium that goes in to make lithium iron phosphate has to be like 99.99% pure.
Okay.
I'm not a mining expert, but let's pretend most places you only get 96% pure out of the ground. So then they have to process it to get it up to a better quality that you can then mix it with things to make what you want. So that's a processing that other people would need to do. And then we got to validate it and test it, go, yeah, that's pretty good. That's the right mix of lithium. It's good. Then who's going to turn that into lithium iron phosphate? And that's what we want. So it's somewhat complicated, but everybody's working hard at it.
Yeah. And I've kind of thought too that probably a lot of the reason why we get our lithium from other countries isn't as much because we don't have lithium here, but because other countries have lower standards when it comes to labor and environmental laws, as far, like lithium mining.
One of the interesting things about the mining part, because you had asked about in the United States versus other places, most of it did go overseas, mostly for economic reasons. It was cheaper and everything else. Or the volumes. No one needed as much volume of lithium iron phosphate because it wasn't really being used to work 30 years ago. Now we need it. But one of the hard parts that I think you and the listeners might want, it's hard to think about, but no one wants it in their backyard. And obviously, no one wants it right outside their house. But we almost have a motto where we want to bring this stuff to the United States, and then no one wants to actually let it happen, get produced here. A little part of me says if it's going to be produced anywhere in the world, well, I'd rather have it done here because I know that our regulators and everybody else and the pollution control systems are going to be good, right? If it's all going to go in the atmosphere of the earth, I'd rather have it being done where we have the right controls, because we know that's not being done in lots of other places in the world.
Yeah, it's always like a catch-22 because we're trying to do all this stuff that's good for the planet and, good for the atmosphere, good for pollution and things like that. But then we have to produce it, which does have some drawbacks that are very much made up for by all the good that we're doing. So, and then some people like to focus on those other things. And then you also have people in other countries that are doing mining with really bad mining practices, and especially when you talk about cobalt in the Congo.
Right. No, absolutely. And then if it's aerosolized, if it's impacting the CO2 or other stuff in the atmosphere, then we're all getting hit with it anyways, eventually, right?
Yeah. And the whole thing, what it's mostly about is we're doing this renewable energy and we need to store it. And renewable energy is solar and wind, and it's intermittent. And so we need these batteries to put it in. And then also too, when you're talking about, lithium, iron, and phosphate, you've got the lithium, and it is super abundant in the universe. It's the third element that was ever made after hydrogen and helium, after the Big Bang. And so there's tons of lithium around, but we do have to refine it. And then we have iron, and they say that the planet Earth, if you put it on a scale by weight, there's more iron than anything else, but iron is really heavy. So it goes down towards the center of the Earth, and then we have that iron core, and then it makes our magnetic compasses work as it's spinning and things like that. And then phosphate, there's, phosphorus is all over the place, and it's essential for life. It's in our DNA. We need phosphorus. And so these things aren't really bad for you. I mean, you could actually even say that iron and phosphorus is essential for life, hemoglobin and all that kind of stuff. And as far as lithium being essential for life, it might not be essential, but it's actually a medicine that people take. So We're talking like very low on the toxicity scale when we're talking about these energy storage systems and those batteries that go inside of the energy storage systems. So how long until your factory is producing like it could?
So we will, by the end of 2025, we think the second half of sounds kind of funny, but the back half of the factory will be built and starting to produce. So that in the end, the actual full length factory, from the early mixing of the raw materials until the battery cells are produced at the other end, it's about 160 feet wide and probably 1,600 or 1,700 feet long. It is really long, right? We're talking 5 football fields plus long. So we're going to build the second half first. I'll call it the prismatic cells that we're doing, the folding, and all that kind of stuff to actually produce the final product, because the chemistry and the mixing is actually the hardest part and takes the longest to get all dialed in properly and working right. And so the thought is we can bring in some already half completed materials in the front part and start doing the back half work while the front half is being finalized and commissioned and all those things. So we can produce some cells using things that are partially produced and we'll take over. And then while we're finishing the rest of it, it also makes it a little bit less complicated for us, because trying to train the workforce on the whole thing at once can be pretty hard. This way we can kind of break it into parts.
Great, great. And you're producing individual prismatic cells, is that right?
Yes. And this first 4 gigawatt hour 2 lines is focused on 314 amp hour cells. So they're probably 3 inches, in thickness, and kind of 6 inches by 8 inches box is what basically we'll produce. That's a golf cart uses about 105 amp hour if you were using a battery. So this is about, and you then would stack all these together to do those storage solutions for homes and businesses and other things.
Wow, that's a pretty big battery cell. So just doing the math from where I'm sitting right now, so I take 314 amp hours and I multiply that by the nominal voltage of a lithium iron phosphate battery, and that is 3.2 volts, and I get almost exactly 1,000 watt hours, which is 1 kilowatt hours per cell. Does that sound right?
Well, I don't like doing public math, but it sounds
okay. But yeah, it looks like somebody designed it for that. So I go 314 times 3.2, and I get 1,004.8. And so that is the math. And so I just do public math all the time. And it sounds like a pretty big battery cell. If we look at a lot of the other ones, they're a lot smaller. And you also told me the dimensions of those cells. So that's pretty neat. When you make the cells, and then you just make the cells and you don't make the packs and everything, I believe. Is that
right?
Correct?
In the end, we'll produce those 310 hour, I'll call them like half a shoebox size. We produce those, and then those are what battery storage solution people will then take those and go, okay, we're going to stack 15 of these together to do this kind of storage, or a larger application would have more of them.
Yeah, and so that's pretty huge. And so you say like half of a shoebox, and it's like, I know my car has these little batteries, and they're like, they're a little bit bigger than a AA battery, smaller than one of those C cell batteries or D cell batteries, something like that. And so this is half a shoebox, quite the large cell. When you're designing a cell like that, do you work on figuring out like how the cells are going to be cooled or battery management systems, or is that something that's done when somebody puts the batteries together into a pack?
Yeah, that's really the pack people. They're looking for is who can provide us US made battery cells. The size we chose is really, we'll have some 105 amp hour smaller ones, but not as many, because the true battery storage to help us with our electrification on the grid and all those things, bigger is better. That's what the battery pack people want. That's why that's the size.
Yeah, and I guess when you have something bigger, we talk about this with inverters and things like that too. You have something that's bigger, you have less of them, and then potentially less points of failure. Another thing that maybe we could talk about too is what a prismatic battery cell is. And so there's typically like 3 different kinds of battery cells. I'll just start with the simplest one, is a pouch. And so you have these different layers, and it's a big rectangle. And then if they roll it up tight and put it in a case, then you get cylindrical. It's cylinder shaped, just like the batteries you put in your flashlight and stuff like that. And then with a prismatic, it's sort of like they take it and they fold it upon itself, I guess, like in a circle. I've heard it being not really a circle, like maybe more like an oval or something like that. I've heard them call it jelly roll. And then they put it in a case. Is that how you might explain prismatic?
Even though it's all one continuous piece, I would call it much more like a deck of cards, right? The cylindrical ones, they tend to wrap it. So you keep wrapping around a circle core, right?
Yep.
And so that's easier and faster to do as people were still figuring this out. So you can coil something much faster than you can fold onto itself. It's only in the last couple of years that the machining for doing the prismatic folding has kind of caught up speed-wise as people figured it out. Mostly in China figured it out. They were first in figuring it out. And so now you no longer have a speed difference. But the value of the prismatic is when you fold it like that, you get a much tighter and consistent density of everything. You don't have the gaps. A similar example would be and this sounds funny, but when you wrap something in a circle, technically the outer part of the circle and the inner part, even if it's really thin membrane, have different pressures on them, right? The inner and the outer of that particular layer of anode cathode material.
Sure.
Well, now there's no difference in this one, right?
Yeah.
And so you end up, that's why you get a longer cycle life and more consistency, because you have just more consistent product.
And I've also heard that same argument with the pouch people. Like sometimes when you see a pouch battery, it's like the one that goes in your phone. A lot of people have seen that. It's sort of like in a Ziploc bag almost, it looks like. And I've heard the pouch people say that too when they are saying why theirs is better than the cylindrical types of batteries. And another analogy I've thought of here too is if we look at the old solar cells, they were circles. So we had monocrystalline silicon, and it was so expensive, it didn't make sense to cut the edges off so we could fit more in a given area. And with yours, I would say that there's a lot less of a rounded corner on it, a rounded part. And so it would be sort of like you would have less of those rounded corners, just like with the monocrystalline silicon of today versus the circular monocrystalline silicon solar cells of 20 or 30 or 40 years ago.
No, I think absolutely. And then you can also think about if you're now a battery storage thing, I use a shoebox example again. Stacking shoeboxes is a lot easier than trying to make the fits tighter than trying to do things that don't have that consistent size.
Like stacking bottles, like the Fiji water, if you're familiar with that.
Right.
It's kind of like a square shaped water bottle. And so you can fit more, you could pack more when you're shipping them out of Fiji.
Right. Same thing.
Great, great. We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSean, that's solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show. And so maybe we could talk a little bit more about like, what's this Gigafactory like? I read something about that it has a lead tensioned fabric membrane. And so lead is leadership for energy and environmental design. There's like lead silver and lead platinum and all different types of lead building specifications. But maybe we could talk a little bit about what the factory is like. And I know you have some pretty neat futuristic looking videos on your website too, which is, I think, what is it? AmericanBatteryFactory.com. Is that right?
Yes, that's it.
Great. And so maybe you can kind of explain what it's going to be like.
Sure, absolutely. What's interesting about it, one of the things that we think is kind of unique is we're trying to bring this battery cell manufacturing to the United States. It doesn't really exist here right now, like we're talking about the scale we're talking about. And so, and many of the machines are made in China, a little bit other places, because the U.S. just hasn't been producing things like that recently. But one of the unique opportunities, I think, is we're probably about 300 people working in this first factory, but they're not all doing what we would all think on the old TV shows, some boring manufacturing thing. This is high-end manufacturing. We have Honeywell and Rockwell and Siemens, world-class expertise and cyber experts who are helping us with the management control systems and all the other things, because we don't want to have a lot of waste. We want to find out the early mixing, let's say the chemical part up front. Is something wrong early before we start making battery cells? You don't want to go to the very end. In the old days, you would go to the very end, you would test some cells and go, oh, they're not very good. We need to go back in and turn things off and change them. But you've already produced how many hundreds or thousands before you found the fault? So we're trying to have a very high-end, using U.S. high-end brain power manufacturing to find defaults as you go. So you early detection to stop it, and also early fixes, but also cuts your recycling tail, right? Every time you have something that's a fault, now you've got waste. So how do you optimize? So we're excited by the opportunity to bring in, I would call it high-end U.S. expertise in an AI kind of way, and that term's overused, to help us do smart manufacturing.
And so when you talk about like being able to do 4 gigawatt hours per year, I think like when a factory talks about that, they go, this is a 4 gigawatt hour factory. And so that's usually per year, I believe, when they talk about doing that. That's a huge amount of batteries. And so I believe we're probably talking about a factory that's cost billions of dollars. Does that sound right?
No, it's not that much. Our initial factory is going to cost somewhere between $400 and $450 million. is what it's
Oh,
called.
that's all. Oh, that's no big deal at all,
Yeah,
right?
it's
No,
just you and I can take it out of our checking accounts, right?
I
There's no
know.
problem.
Yeah, I'll
Right?
write you a check right
Yeah.
now. Okay.
So I mean, that's big money, obviously.
Hmm. Oh,
But
yeah.
you know, you're building. There's the construction part. You're building a very long, skinny building, which is kind of weird and unique. Then the machining. So that's just to have it start to work. Just to give you a sense of the raw material part, our estimate of kind of current pricing of a mix of U.S., European, and Asian raw materials, depending on who has enough quantity. Eventually, we hope to be obviously all U.S. It's probably $30 million a month just for the raw materials coming in.
Wow.
So that gives you
Oh,
some sense of the stuff, just that production throughput, how it would operate.
yeah, and it's probably more expensive as you get the materials from places where they treat the workers better and things like that too.
I mean, we get some help in the government, not helping us now, but in the long run, as we start doing this, the tax credits and other things can help with that, or the suppliers that are working on their supply chain through government help and local help. That should help them become more competitive and drive down pricing a little bit.
Great. And so you were talking a little bit about chemical mixing. Maybe you could educate us a little bit on what that entails.
Sure, I'll take a stab at it. But fortunately for me, we have a PhD material science expert. So we can always do a follow up with him who could talk chemistry till everybody's blue in the face.
Okay.
But
Well,
essentially,
we might
real
understand it better coming from you. The smart people are hard to understand.
so the real challenge you kind of have is you got to produce the anode and the cathode material that come in, right, to do this, right? And so we're going to theoretically get from inside the US, the lithium iron phosphate, and then you have to bring that in and you have to basically mix, you have to come up with your mixture, right? And we have our mixture, but you can slightly change the chemistry, right? Which can slightly improve or change the outcome at the far end. But then the challenge is you need to take that material, right? And you're going to now produce those anode and cathode layers, right? And so you have the very, very narrow coating kind of process. Because one of the hard parts is you have to have, I'll give you an example of the anode material. The anode is basically graphite, but it's isotropic graphite, which means it's got to be very common shape in all directions, right? Very consistent. And so you're kind of making layers of the anode, and eventually you're doing layers of anode, layers of cathode, layers of anode, layers of cathode. But you got to bring those materials in, get them ready, and then you have to use, at this point, typically using liquid means, I'll use the term spray, to spread that film very evenly, right, and consistently, really, really narrow film. We're talking millimeter, 2 millimeter, really tiny, parts of a millimeter. So how do you do that in a consistent way where you're making sure the humidity is not too high and all these other things? That's the challenge of this stuff is you can make it, but if you want to make it consistent and it gives good power output and it lasts a long time, then consistency is really, really important.
Yeah, and so the anode typically for most any lithium-ion battery is graphite and sometimes mixed in with things like silicon. And so you were saying it has to be very thin like that. Kind of reminds me of when we talk about thin film solar modules and things like that. And then when people usually mention what type of battery they have, they're talking about the cathode. And so that would be the lithium iron phosphate.
Absolutely correct. And then anode has to have that crystallized structure, right? That's the isotropic part, because I call it the spacing, even though it's too tiny for us to see. You need that spacing to allow, in the long run for the isotopes to flow.
And so then you have the cathode.
Correct. And so it's getting those two materials I use the term pure, but I mean, they're obviously a mix of things, but getting very, very high and very consistent. Because you can think about if the next month you're bringing in another mix of lithium iron phosphate and throwing it into the vats and getting it ready to go do what you're going to do, right? And spread these films and everything else. Is it different than last month's, right? Because that might affect your ability to do the prismatic folding because it's slightly different. Or you're not going to get the same ability, like its absorption capacity for the ions to flow. And all those other things can be different. So you have a consistency across the board that you have to meet. Otherwise, how do you guarantee, your reliability and your lifespan?
So when you say it sounds like you're putting lithium iron phosphate in a vat. So do you buy these components separately and then put them in a mixing bowl type of thing, just for an analogy?
It's not just lithium iron phosphate that gets mixed in, but we're trying to not be, at least initially, we're not trying to be lithium and iron and phosphate and buying those and mixing them ourselves. We're working with people that are trying to produce the already complete LFP. Because essentially what you do is you take very high quality lithium, certain types of iron and phosphate, and then you have to blend those in a right proportion and you heat those up. And that's what gives you the lithium iron phosphate, right?
Great.
And so we're not trying to be the main mixer of LFP in the long run, but we need to bring everything in and do them in combine things in a certain way.
So somebody has like an LFP mix that has all the right ratios and all the right consistencies, and then they sell it to you?
We would be telling them what mix we want, and then they would go mix it.
And then you bring it into
And then
the factory.
in other words, we're instead of us making our own lithium iron phosphate heat up place, we're asking somebody else to do it for us.
Great. And then also you have a separator too. Is there a particular type of separator that you're using that's going between the anode and the cathode where the lithium ions go through the separator?
I'm not sure I would say unique. We talked about lithium iron phosphate, obviously. We talked a little bit about graphite. There's about 15 or so materials that are kind of the main essentials across the board. There's some foils. There's the can for going around it. There's separators. There's slight differences between different ones, but we're basically right now, using the separator example, working with 3 or 4 US companies that are all trying to be in the separator business as they work through their quality and everything else. And so that's the art and science of what we're doing, is working with 3 or 4 different US people on all these different main components. Because I'll give you an example in tin cans. The tin can that goes around it is aluminum, certain way, something else. Well, no one makes them right now. Nobody does the canning of these kind of battery cells right now in the US, really, at scale. But we make a lot of cans for food, right?
Sure.
And so it isn't that we're incapable. So we're actually working with some people that are, some of the canning people that are going, hey, we could probably do this. So they're doing this similar to what we're doing on the battery cell production. They're thinking about how could they provide those early precursor parts that we need for those 10 or 15 main things.
Great. And so I know that we're talking about stationary energy storage systems. Is there any thoughts about putting them in electric vehicles, or is it specifically for stationary energy storage systems?
No, we're not exclusive to that. I've just mentioned that because that's easier for most people to imagine in terms of, because I personally, this is a John Kim view, I think the battery storage solution is the most important part if you talk about, because of the challenge of our reliability of our grid, more and more power demands, all the demands of all these big computer farms, you know, the Intel and Amazons and all these people of the world that are trying to do more AI, and you need more compute. Well, all those things need lots of power. And our grid, even if we produce more solar, we have no ability to move enough power around to where it's needed when it's needed right now. And so the solution to that is, if half the homes in America, or a third of the homes in America, had battery storage of 8 to 12 hours, you could now have a smart grid where you could move the power around to who needs it when, and you could take advantage of all these opportunities. We don't have that right now. That's why we talk about battery storage solutions a lot, but it's not exclusive. We have, I'll use some funny examples. We have people from the golf cart, the small industrial machining, who are all interested, and they would use, you know, typically some of them might use the big battery, but some of them might use like 105 amp hour, because that's what you need for smaller vehicles. In mining applications, there are people that do underground mining and other things. They're looking for something that way you don't have to have gasoline or diesel powered underground vehicles, and you get rid of that.
Carbon monoxide doesn't smell too good.
All that stuff.
Even though you can't
There's lots of interest in using this kind of battery for other purposes. And right now for cars, people haven't up until now used LFP, like you said at the very beginning of the podcast, because it doesn't quite give you the same peak power. And so when you were trying to get a car from 0 to 60 really fast to compete, because that's what you were bragging about, well, then you want peak power. But for most solutions, even for most industrial applications for vehicles, you're not trying to go from 0 to 60 in 1.2 seconds. But if you have consistent, reliable power and it doesn't catch on fire, so there are certainly vehicle applications, I think.
Oh, sure, yeah. Yeah, I mean, my girlfriend has a Tesla Model 3 that is LFP. And so I think there's a lot of them out there. And I think in China, I think it might even be a majority of the cars are LFP. I'm not sure about that, but who needs to go drag racing anyway?
Right. You're trying to get around town, and if it's cheaper, more reliable, and lasts longer, well, that's a more economic way to do it. So yes, there is a increasing use in, I'll call them in the car thing, but I said for mobile applications, it's increasingly got some real unique places to use it.
Yeah, great. Because it sounds like I would think that your types of batteries would probably be a great idea to have in cars. I think one of the reasons why they did go to cobalt first for the electric vehicles is because of what they call range anxiety. And so people were a little bit freaked out because they're going, well, if I want to drive to New York today from San Francisco, what am I going to do? I'll have to stop in, all these different times, or I want to be able to go 500 miles and things like that. And then as people are more and more used to electric vehicles, they don't have to worry. They're just like, oh, that's no big deal. I just plug it in when I go to sleep at night and I wake up every morning with full of a charge as I want.
Absolutely.
And are you looking at putting your batteries also like in homes and giant gigawatt scale energy storage systems, like every different size?
Well, we have I use the term offtake. The people who want our battery cells, that's what they do. We know they'll be used for battery storage and gigawatt scale things, but we're not the OEM, for lack of a better term, who's going to do those things. I'm telling you, if we had 4 gigawatt hours being produced right now, they would all be bought because everybody wants them.
Yeah, and what is the benefit for having made in America batteries? I know that you already, without anything made in America, can still get 30% investment tax credit for an energy storage system, even when it's not co-located with solar, since they implemented the IRA last year. But what other kind of benefits can you get? I know that with solar projects, you can theoretically get up to 70% of an ITC investment tax credit. And I don't think anybody's even done that yet because you would need to make everything in the United States, have it installed by people with low incomes, and also put it in a place like an old coal mine where like an old energy infrastructure from something that used to pollute, something like that. So where can you go with your batteries, with Made in America batteries?
Yeah, it's funny you made that comment because in many ways, if you go read through the tax code, it's almost like a Christmas tree of the good idea fairy. And you sit and you're going, and then the bragging part would be, you can get a 75% of this, but you're like, there's no place in the United States that actually all those things would apply. But it's kind of funny, right? In a weird government kind of way. First of all, some of those tax credits, they're not going to last forever, right? There's nothing to do with who's president or politics or anything else. They're just not going to be there forever. So we want to make sure, firstly, that we are competitive to be able to manufacture. We're about being a good manufacturing business, not we can only survive off tax credits. So that's why we benefit from some of our folks who have long experience of making profitable manufacturing organizations, because you have to be able to do that, right? Because in the long run, whether it's China or other places, you can be slightly more expensive. Made in America is worth something, right?
Sure.
But it's not worth 3 times the cost, right? It's just not, right? People aren't going to be happy with that. You have some challenges now. I've been recently reading about some of the companies are saying they're made in America or made in North America, but almost all the raw materials are being made in China. And then they're just being final assembled in Mexico. And then they're getting all the tax credits and everything else. And you're like, that's not the purpose, right? So it'll be interesting to see how this plays out in the next couple of years.
Yeah, I know. I was thinking when it was called American Battery Factory, it's like, that sounds like the name that some Chinese company might give their company, because you have Canadian Solar. And of course, Canadian Solar is mostly made in China. And you have another company called AmeriSolar, which is made in China. I was thinking about myself starting an American company and calling it China Solar or China Battery Factory, and then sell it in China. I'm just kidding.
Perfect. No, I guess you're right. We're an American company, but you're right. Because we're all only, 150 characters deep half the time, you never quite know what's sticking with people's brains.
Yeah, and nothing against Chinese people too. I always want to point that out. Some of my favorite people in the world are from China and born in China and things like that. And it is good to see that when the smartest people in the world come here and work, I like to see that they come here to work and keep the knowledge here. There's a lot of controversy in the world about different things going on, but maybe we don't need to go there.
I think towards your point, I think one of the things, because I've lived in Europe and I haven't lived in Asia, but one of the things that Americans in our society is very entrepreneurial. There's a reason Amazon and Tesla and Walmart and Marriott and all these companies that are world renowned, and Honeywell and Rockwell, all these other ones I mentioned, because the ability to really think and be entrepreneurial is pretty powerful, right?
Yeah, and you see over in places like Silicon Valley, there's a lot of people that are born everywhere in the world, and they're some of the smartest people in the world, and they decide to come here. And I think it's a good thing, I think, in my opinion. It's good for America to have the smartest people in the world here. Like you could see that CEOs of some of the biggest companies were not born here, and they're American companies.
Absolutely.
So let's see. So is there anything else that we should be talking about that we didn't cover?
No, we've obviously covered a lot of ground. I think the just to go back on what we think is the real value-added solution of American Battery Factory is energy storage is the only solution that makes the long-term electrification and reduce CO2 goals of the United States possible. Wind and solar aren't getting there very quickly. And even with improvements, our goals by 2035, 2040, we're never going to be able to get there if we don't have a storage system that allows you to do that. And we're positive that ABF battery cells and these kind of things are so important to getting there. So we're excited to be underway.
I'm really excited about all of this made in America stuff. I mean, it's like a lot of times the Americans, like with labs like NREL and Sandia and things like that, come up with all these great ideas and great things to build, like solar modules and lithium-ion batteries. All kinds of technology comes from the United States, and then it ends up being made somewhere else. And so I'm pretty excited about the prospects of making things here and all the things that are going on with the Inflation Reduction Act and all that. And so thank you so much for helping and make that happen. And I was also wondering too, how can we help? And is there ways to invest in the American Battery Factory or promote the American Battery Factory or keep a lookout for when we can buy products that have your batteries in them?
Yeah, in terms of products, you can have it in it. We're not going to be producing at a decent quantity until late 25, early 26. So, another 18, 24 months before you're going to be able to start seeing that, because there's also the lag effect of people that do battery storage solutions have their own supply chain where they want to have a 2-month supply on hand or 4-month supply on hand, right, as it's coming through. So that's a little ways off. In terms of investing, I would say just pay attention to our website because we're privately held right now, but not and we're going to be going through a Series B shortly. And down the road, there'll be opportunities, I think, to invest. At this moment, we're still not figuring some of that part out.
Great. And do you mind if I ask you too? I always hear people talking about Series A and Series B. What does that mean?
Those are kind of, I'll call them a Wall Street term for when you're raising money early in a company's. And so the first raising of money would be called a Series A. And you get a few people who invest and they get either some stock, different kinds of stock, different kinds of debt, and all those kind of things. And that gives you some starting money to get things going. And at some point, you're ready to expand at a greater rate. And so you need more capital to go do some of that factory work or machining work. And so then you would do a Series B, and then you would raise some more money, right? And then, I'll make this up because I'm making this come ahead, but Tesla might have done that, and then they did a Series C down the road. Then it was a Series D. So it's more of a term on a fundraising thing, but, the first one is called a Series A, and then a Series B, and then you can keep doing more potentially.
And so these would probably be with accredited investors that have a certain amount of money that they could afford to lose and venture capitalists and things like that.
Well, I would say, I'm not a Wall Street guy, but that's typically who is looking for these kind of opportunities, right? But it's not exclusively. It doesn't have to be just them, and it doesn't prevent other groups from trying to be part of it. There's people that's who they live and breathe, right? That's what they do all. Most of us don't have the money like me. We don't live like that, right?
Like if I knew somebody that wanted to take their IRA and invest it in the American Battery Factory, they couldn't really do that right now at this point.
Not at this point. No.
Yeah. Okay. But maybe you'll go public.
Well, that's what often, we're nowhere near that anytime soon. But in the long run, our goal is not about going public and all those other kind of things. It really is trying to bring this capacity back to the United States and do it here.
Great. So let's see, where can people find out more about you and the American Battery Factory?
You can go to our website, AmericanBatteryFactory.com, and that has a place with some more background. It updates now and then. We'll have some media things released there. There's a place as we get into not right this moment, but in the coming year, that's where we'll be people that are that do manufacturing and looking for work. That's one of the places we'll be looking for expertise and tradesmen and other people to start doing that stuff in the coming year.
Great. I can't wait to look out for your batteries coming out in a couple of short years. I'm sure that'll roll around in no time. And I'm going to see some of your batteries and just brag about how I had this general on my podcast. By the way, John Kim, do you have the President of the United States on speed dial?
I've never met former President Trump or President Biden.
Okay. All right. Well, I'm sure you will someday because they're going to be touring your factory bragging about how batteries are made in America. In fact, we do have an election coming up, and so maybe it'll be sooner rather than later. Thanks so much for being on the podcast, John.
Thanks very much, Sean. And just one last comment, because I've worked on Capitol Hill. In the end, everybody will find a way to try to be anti the other group. So we're happy just doing our job.
Yeah, and I know we see in politics that people are always fighting against each other, trying to make them look so different, but we're all the same. We're all Americans, and let's all work together.
Absolutely. I agree, Sean. Thank you.
Thanks, John Kim, for being on Sean White's Solar and Energy Storage podcast. To find out more about solar and energy storage, such as lithium iron phosphate batteries, go to SolarSean, that's SolarSean.com, and get yourself NABCEP Energy Storage Installation Professional, that's ESIP certified.